welcome in the class of engineering hydrology. So, this is the first class of this subject. So, today I will give you the overview on the subject. Okay. So, first of all let us see what is engineering hydrology. What is engineering hydrology? So, engineering hydrology it is a study of science of water. It is study of science of water. Okay. And this science is related with the availability of the water in the planet, availability of the water in the planet. Okay. So, what and how and where, what the quantity will be available, what the forecasting procedure we should follow, okay, what the type of procedures in case of droughts, okay, in case of flooding. So, this type of thing we are going to study under hydrology, okay, under hydrology, availability of water within the planet. Okay. Hydrology deals with the occurrence, okay, with the occurrence, movement, distribution and circulation of water above the ground, below the ground or even in the atmosphere, right. Occurrence, movement, distribution, okay. Circulation means different forms of the water. Water is available in our atmosphere as moisture, okay. When sunlight, okay, this is the part of actually hydrological cycle. After in this class I will tell you what are the different forms of the water. Okay. In this subject this hydrology we also study about the replenishment of the water resources, replenishment of the water resource, okay, this is the extra replenishment of water resources. Okay. So, this is all about hydrology. Okay. Since engineering is there, so that is why we will apply the principles, theorems that is given by meteorology, it will be used, okay, in defining the in solving the problems. Okay. So, in objective, ultimate objective of the engineering hydrology, okay, that the ultimate objective of the engineering hydrology can be understood through this picture. Okay. Suppose this is our study area, okay, this is our study area. Okay. In technical word it is defined as catchment system, it is defined by catchment system or catchment area. Okay. Suppose certain quantity of the water is entering to this catchment area, certain water, okay. That water may be in terms of precipitation, okay. The major source of the water in this planet is what? Precipitation, okay. The groundwater abstraction is also another process, but the main is through precipitation actually. The input is precipitation, okay. This rainfall, the major part of the rainfall will not be available to this catchment area. The part of the water which is available to catchment area, that is useful, that will be useful to that. And what will be the major part of, what are the losses? Losses is in terms of runoff, means depending upon the slope, if the precipitation is here, then it will be water will move depending upon the gravity, okay, depending upon the gravity. If suppose in the path, okay, in the path if there are the streams, okay, ponds, so the water will enter to this these ponds, then again it will flow on the surface, flow on the ground surface. Okay. So, this is what? This is actually runoff. Okay. Since this is moving in earth surface, this is it is surface runoff. Okay. Surface runoff. So, after this loss, the water which is available to catchment system is again going to penetrate within the ground. Okay. Since some part of the water is going to penetrate inside to the ground. So, there will be some losses. Okay. Catchment losses going to penetrate or due to presence of the sunlight. Okay. Some part will be the evaporation, infiltration, etc. There will be some losses. So, the useful water, the quantity of the useful water that we need to calculate here in terms of this input, this output, these are the basically output, losses means output. Okay. And engineering our engineering work is to manage all the situation in such a manner that the requirement of the requirement within the catchment area should be done in proper manner. Okay. That is the objective, all the requirements. Suppose in within this catchment area there is the agricultural land, then the water required for the agriculture purpose must be available throughout the crop period, okay, throughout the crop period. Okay. So, the next thing, let us talk on the applications of engineering hydrology. Okay. Applications of engineering hydrology. Okay. So, these are few areas where engineering hydrology is very helpful. Okay. In designing the hydraulic structures, okay, hydraulic structures, okay, like dams, okay, like canals, okay, like superpasses, okay, 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 any type of, and so many more, any type of hydraulic structures. So, if we are going to construct the dam and we do not have the clear position of the availability of the water, then it will be difficult. Therefore, prior to design a dam, we must have the data of at least last 25 to 40 years at least, so that we can decide the different conditions, different elements of the dam, okay, prior to and different location, and many more things, many more parameters that we need to decide. Okay. So, okay, the data of last 25 years, say 25 years, okay, that is too difficult. The maintenance of this data is too difficult. Okay. At a certain time, suppose some data is missing, then what should we do? And this is very common practice. Okay. Say for an example, some data it is not consistent with the other data, then what we should do? Then it means we should have some techniques. Okay. So, engineering hydrology gives the idea to have such type of data and that is used in hydraulic structures. Hydraulic structure. Okay. Hydraulic structure cannot be designed without the availability of the water, without the clear knowledge of the availability of the water. Okay. The next application, it is flood forecasting. It is flood forecasting and the management. Okay. Of course, flood is undesirable thing. Okay. And if we have some idea, if we have the methods of flood forecasting. Okay. Method of flood forecasting means what? Say say at this river dam is constructed. Okay. This dam is constructed. Okay. Dam is constructed in this dam. This dam is constructed. Okay. Dam is constructed. So, and the water is, okay, this is the dam. Okay. Water is stored here. Okay. Due to certain conditions, okay, if the water has to be released, okay, water has to be released, then this water, how this water is going to affect the nearby areas. Okay. If that water has to be released, then how by which extent or by in what manner it is going to affect, okay, that we need to calculate. Okay. That we need to calculate, and it is through the forecasting methods of engineering hydrology. Okay. So, this is the next application. This is the next application is irrigation. Okay. It is very the ideas, the concept of engineering hydrology is helpful in irrigation system. Okay. We are going if we are going to design a canal, okay, then if we do not have the idea of the availability of the water, what the water is to be flowing within that canal, then we cannot be we will not be able to design. Okay. So, in irrigation. Okay. Next, municipal and industrial water supply. Okay. It is essential that water supply system for doing for municipal and industrial water. Okay. The requirement of water to municipality and for industry. Okay. That requirement is based on the hydrology, water requirement. Okay. Water requirement is known to us, but from where that requirement will be completed, okay, that comes from the hydrology. Okay. Water requirement for industry, okay, say X is the quantity of the water required, okay, from industry, from municipal, suppose say Y quantity of the water is required. Okay. Then how, from where that water will be available, okay, that tells, that is the part of the hydrology, okay. And its next is hydropower generation. Okay. Hydropower generation, in hydropower generation we know that very huge quantity of the water is required. Okay. Water is entering in the turbine through a very through a height, okay, to rotate the turbine. So, the and the power electricity has to be provided throughout the year. Okay. It is not the means that okay, for this particular month the water is available and the it is turbine is in working. So, we are getting the power. Okay. The power has to be supplied throughout the year, and for that we need the water in proper reservoirs, proper dams to make the availability to of power. Okay. In pollution control, okay. In pollution control, of course, there is the requirement of the water, there is the requirement of water. Okay. So, water demand comes from pollution control, and that demand has to be completed, fulfilled by this. In the next application is navigation. Okay. Navigation, for navigation purpose in tourism, that is required, water is required, a huge quantity of the water is required, and it is not throughout the year, it is not throughout the year, some particular seasons, some particular months of the time water is required. So, the availability, availability of the water in particular time period, that is much important. Okay. Drought management, of course, with the knowledge of availability of the water. Okay. If we know that this much quantity of the water will be available, and if our demand is beyond that, then therefore, we need to develop certain management. Okay. Certain management. Okay. So, that was the these are some applications, these are some major applications of the engineering hydrology, right. The next thing is world water resources. Okay. That we should know that what are the availability of the water. Okay. What are the availability of the water. Okay. So, we know that the total water available to us, it is 1380, it is it is how much, it is 1380 million kilometer square, square. This is the total water available in our planet, total quantity of the water available. Okay. And out of this total quantity, this is the total quantity, this is the total quantity, and out of this total quantity, we know that 97.2% of the water, that is with oceans, and therefore, it is saline, therefore, it is saline. Okay. Therefore, it is saline. So, 92% of water, okay, the available to us, that is not in any use, it is not in any direct use, means in terms of our domestic or industry. Okay. It is its usefulness is, and out of the remaining is how much, 2.8. Okay. If this is 100, if this is 100, so the remaining is 2.8%. Okay. Out of this 2.8% of water, out of this 2.8%, okay, this is actually fresh water. Okay. This is fresh water, 2.8% of the total water, it is fresh, but this fresh water, okay, this total fresh water is also not available to us. Okay. Is also not available to us. Okay. Out of this major part, 2.15%, major part 2.15% is stored within the glaciers, okay, in polar ice caps, major part. Okay. And so, what is the remaining 2.8 and this one. So, this one and some part of the water, some part 0.32% of the water, that water is available in the ground. Okay. Depth at 800 meter below the ground, 800 meter below the ground. Okay. 800 meter below the ground. So, the remaining quantity of the water is very less, and it is only 0.33%. It is only 0.33% of total water available for human use and for its consumption. Okay. So, the quantity of the water 1380 million, okay, million square cubic kilometer, that turns only 4.5 million cubic kilometer square. Okay. So, this much quantity of the water, it is available in our planet, it is available in our planet. Okay. And through hydrological cycle we will see that the availability of the water in the planet, it is going to it is going to change in different stages, means that much of water is only available to us by through different forms of the water, say precipitation, say snowfall, say sleet, so many more things. Okay. And this water, 0.33% of the water which is available to us for human use, throughout worldwide we have the annual precipitation, as 100 centimeter. It is an estimation that 100 centimeter of the precipitation is received throughout the year. Okay. Annually we receive 100 centimeter of the precipitation. Okay. Now, what is the resource of what is the water resource in our India? Okay. In our India, first of all the input is average annual precipitation. Okay. That is the input, actually that is the input for the water resource, and it is 119.4 centimeter. Okay. It is 119.4 centimeter against the annual average precipitation of world as 100 centimeter, right. And its geographical area, it is 3.28 into 10 to power 6 kilometer square. Therefore, total quantity of the water available, it is how much? 3916 cubic kilometer. Okay. So, this much of the water is available to us through precipitation. Okay. And since we know that this available water has to go certain losses. Okay. This one water, okay, 3196, okay, including snowfall, total water. Okay, this is due to precipitation, and due to snowfall and total water participation, it is a 4000. It is 4000 kilometer square. So, out of this 4000 kilometer square, okay, we must have the calculation for its losses. Must have the calculation for the losses. The calculation for the losses, first the major loss is for evaporation. Okay, evaporation loss, and it has been estimated that the out of this 700 cubic kilometer, it is going to loss. It is going to loss every year. It is going to loss. Okay. The next part of the water, it is water soaked into ground, and it is 2150 infiltrated. That this much part of the water is going to infiltrate to the ground. Okay. So, the net water available is how much? The net water available is 1150 only kilometer square. Okay. The available of water is only that, net available water is only 1150, right. So, out of total 4000, okay, out of total 4000 we have this much part of the water. Okay. And if we compare the percentage what's water available within India, then it will be how much? It will be 1150 divided by total worldwide is what? Worldwide it is worldwide it is where? Yeah, this one 4.5. Okay. It is 4.5 5. So, it is 4.5 into 10 to power 6 into 100. So, it comes to be 0.025%, 0.025% the worth water available within the India. Okay. So, the next thing is next thing is so this is the idea, this is the idea that actually that data gives the idea, that data gives the idea how the management of the water is to be there, what should be the procedure, how different losses can be minimized, evaporation loss, it is a very common, we cannot do much more, we cannot do much more. Evaporation loss, sunlight is there, if sunlight is there, and it is open to atmosphere, it is the common process, we cannot remove. But what we can do, what the engineering practice can be done, the engineering practices can be done by changing the cultivation agriculture process, technique of the agriculture, so that same quantity of the water is available to more plant. Infiltration, water infiltration, it is also unavoidable, also unavoidable. So, so the engineering hydrology is a very challenging task to have certain type of data. At the last, I would like to tell you the different forms of the water, different forms of the water. Different forms of the water, it is basically hydrological cycle, it is the hydrological cycle. So, water hydrological cycle is what? It is a water circulating cycle. It is water circulating cycle which shows how water is how water circulates from one place to other place, from one farm to another farm with the time, And the component of the hydrological cycle, it is precipitation, evaporation, transpiration. Precipitation is what? Precipitation, we know rainfall, rainfall. We are also different forms of rainfall that we will discuss in next class. Evaporation, presence of sun heat in the earth is the responsible for this evaporation. Transpiration through plants, the water, evaporation of the water, transpirated, evapotranspiration need, transpiration, plant, the requirement of the water by plant, evapotranspiration, through leaves, plant, the water going in to atmosphere, infiltration, input water which is infiltrated to the ground, that is infiltration, runoff, apart from that the water which is moving on the surface, that is runoff. So, these are different forms of the water, and the water budget equation is input that is input minus output. Output is equal to capacity at any catchment area, right. So, today we talked different objectives, different applications, different forms of the waters. In the next class, we will be continuing on the next topic of the hydrology. Thank you very much.